Hi everybody, welcome back. So in this short video, I'm going to talk a little bit about why C programming. There's lots of different languages out there, tons available, new ones being created all the time, but we're going to spend the first 2/3 of the class learning a programming language called C, and the last 1/3 of the class using a different language called Java. And we'll talk more about Java later on, but I wanted to focus this short video on saying, well, why C? What is the little bit about the language, some of the history of the language, and why do we care? Why do we spend the time learning this versus other alternatives? Okay. Well, first of all, I do want to point out, because I think this is very important, and I think this is something that's worth mentioning at the onset here, is that the primary goal of this class is actually independent of any sort of particular programming language, right? Lots of different languages out there. One thing that you'll find is these languages tend to have a lot of similar things, some concepts, the way of thinking, very, very similar across lots of different languages, programming languages, and the ability to kind of break down a problem into small little steps, being able to code smaller pieces of a larger problem, putting them together, kind of thinking, and this is kind of in some ways referred to as like algorithmic thinking. That's really at the heart of it, right? Effectively, what am I getting at is I care about your ability to problem solve, right? Your ability to solve problems using programming as an important tool of that process, okay? Now that's independent of any language, right? So, if, having experience in doing languages such as Python or even MATLAB or Java, or there's tons and tons of different languages out there, those are all super helpful. You'll find tons of similarities, okay? Now, it's almost like learning in different natural languages. If somebody knows how to speak Spanish, they're going to have an easier time picking up French and so on, right? And there's a lot of different similarities between programming languages the same way, okay? So you will find that over time, right? You learn one, you learn two languages, you're going to pick up others faster and faster, and it gets easier to jump between different languages. Okay, so, well, to understand why C programming language, we spend the time learning it, it makes a little bit sense to go through a bit of the history of C programming. C has been around a really long time, and is the history of it is really ancient in the sense of computing languages, but you can kind of trace it back into some of the first languages to being developed like back in the 60s. So there was a language, and I'll actually talk about how it has that name C to begin with. How did that come from? All right. So there was a language in the 60s called Algol, and was at the time, it was quite forward thinking. And there was into the 70s there was a follow-up language that was kind of a more powerful extension, more advanced extension. And they took the fact that Algol started with a letter A, and it was like a kind of a successor, and so they called it B, right? They called it B as a way of being like, this is like the next language in a sequence. And something similar happened shortly afterwards. A successor of the B language came the core traditional C language, right? Now, that was developed in the 70s. A lot has happened since then, right? But a lot of the foundational ways in which computing systems work has stayed the same. All right, so there's been different standards that have come out over the years, kind of basically tweaking, modifying, improving the C language, many different standards. We're going to use the C11 standard in here, developed in 2011, although there's now a 2018 version, but because of availability and everything, we're going to stick with the 2011 one. So the language has not been static. It's been changing, and the standard's been growing over the years. But C as a language has had an awful lot of staying power. I'm gonna explain why in a moment. Right? It's widely popular. Okay, and one of the things that you'll learn over time is that I would argue is there is no such thing as the quote unquote best programming language. Okay, programming languages, there's lots of them. They are designed to be good at certain things. So all programming languages have advantages and disadvantages. And the proper programming language to use is dependent on the problem you're solving, right? Certain problems are better suited for certain languages versus others. So it's not like a single tool that can solve all sorts of problems, right? Now, a lot of that comes from experience. You're only going to kind of understand so much of that in the context of a class, okay? Now, there's C programming is really great for in the context of something called systems programming. You could actually take a whole class in that later on here at your time at UAlbany if you choose to. And there's things called operating systems. You could also take a class in operating systems and embedded systems, and you're actually going to be exposed to some embedded systems as part of your degree. And so systems programming has a lot to do with underlying hardware and management of hardware resources. And C programming tends to be the go-to, in that almost all operating systems and embedded systems tend to be written in C. Okay, now why is that, right? Well, without getting too into the weeds here, I'm going to kind of just stick with the kind of generic reasons why. And over time, as we kind of gain some more experience and see what the language can do, and also compare it to another language that you're going to see in this class, you're going to get a better sense of the advantages and disadvantages of different languages. So let's just use an analogy for now to talk about what C as a language allows. Okay. Now, a lot of languages, you can think of an analogy as like a train, right? So think of a language like Python, which I'm assuming you've never seen, okay? Or languages even such as Java, which you will see. You can think of them kind of like a train, right? A train can move an awful lot of stuff, right? A train can move a lot of things and can do an awful lot of work, but there's limitations, right? It's stuck on the tracks. It can only go in certain directions, so it can do an awful lot. It can be very efficient. It can, it can kind of have like a lot of, do a lot of work. But it has a limitation in the fact that it's designed to go in certain fixed routes. Okay, so that's kind of a rough analogy of how some of these kind of quote higher level languages like Python and Java work, right? They can do an awful lot. They're exceptionally powerful and great to know. Okay, but there's certain things they don't do or don't do very well. Okay, now C is different. It's designed differently. Okay, C would almost be like the analogy of walking, or maybe walking with a backpack, right? You're not carrying an awful lot. It's hard to get a lot done if being done is like moving something from point A to point B, right? It takes an awful lot of work to do that. But it has an awful lot of control, right? You can go in all different directions, right? You can change course. You're not limited to these different tracks. Okay, so sometimes, right, it can be awfully hard to get things working in C, to get a lot of work done in C, but you have this ability to control things and have an awful lot of flexibility. So that's why I would get to is that it just depends on what problem you're solving, right? Certain problems are better for certain languages versus the others. And what we're going to see, though, initially, especially in an intro class, is the fundamentals, right? The fundamentals are exceptionally similar across these different languages, okay? So the fundamentals are really going to stay the same, okay? And we'll just see some nuanced differences between the two that we'll cover in this class. And it's by no means we're not covering everything. There's certain stuff that's just not realistic to fit into a semester. So we're going to cover a certain amount of material and give a strong foundation in these things, okay? So, another thing just to mention, C is a building block, right? It's because it has this level of control, that it has this ability to manage certain kind of system resources directly and explicitly. It's a building block. It's a building block that a lot of languages are built on top of. So other languages, right? And that's one of the big reasons why it still has such staying power after decades. Is it's a core fundamental building block to building other functionality, right? So a lot of things are built on top of C, okay? Or very, very widely used. Engineers, right? Electrical and computer engineers, we learn C, right? If you recognize this picture from a previous video, we learned C because we're really interested in computing systems, right? We're looking at computing systems, and if we take a look at, say, a complicated system such as a jet engine, right? Well, a jet engine has all sorts of complicated things going on. It has mechanical stuff going on, right? It has electrical work going on. It also has an awful lot of computation going on in there too, right? It's a computing system that has all sorts of logic and sensors managing this complicated system, right? This is a form of called an embedded system in which you're having code logic and computing systems embedded in some sort of special purpose device, right? And C allows that kind of control of the system's resources and really good for systems such as this, right? I have a cousin, for example, who works for Boeing and actually writes C code for their engines, right? Maybe not the best place to be in after all the fiascos they've had with some of the problems in their software logic that's led to some flights going down, unfortunately. But they, it gives you a sense of how dependent these systems are on computational management of this kind of complex behavior of these systems, right? So there's sensors that are determining how much thrust and all managing fuel and all sorts of aspects of it. Very, very complicated, a ton of testing and everything that has to go on for these. C as a language, to kind of just point out why C is, it's a language that tends to be very good at these types of things where you have these, embedded systems that might have a mechanical component. So you might be working with a mechanical engineers as part of it. They have an electrical component, but they've also got special purpose computing resources in there managing the system and being like the brain behind the system, right? And C is really the go-to language for those types of problems. Okay. Now I'm going to leave it like that for now. Going any kind of deeper, I think, into what, the differences of different languages and everything probably makes more sense to do after you've learned some more, some fundamentals, going in and actually getting some programming experience, right? This is something that could be reflected on later on after you get some hands-on experience building some stuff. Okay. All right. So we'll leave it at that. And pretty soon we're going to actually be able to get our hands dirty and start building some things. Okay. And we'll just build it from the ground up, one step at a time. Okay.